Alright, this is lesson 4 for 7th grade, and we're talking about the number line and sequences today. This is our regular number line. All of our integers basically all the way up into infinity in the positive direction and all the way to negative infinity in the negative direction. We're not talking decimals or anything like that yet. These are all integers. So, as I was saying, number line with just the integers includes counting numbers and all of their opposites and the number 0. The number 0 is also called our origin. Alright, so all the numbers to the left of the 0 are negative, and the further that we go left, the smaller they get. All the numbers to the right are positive, and the further right we go, the greater the number will be. And if we were to take just these numbers here and write the integers as a set, we could write them like this. These dots here, this means it's going to continue in this pattern forever in the negative direction, and continue in this direction, in the positive direction forever with that same pattern. Closed in by brackets or braces. So that's how we would write it as a set, and that's something that's going to come up quite a bit in the following years. So something to pay attention to. Alright, so with the number line, as we said, we had negative and positive numbers. So we want to be able to decipher which numbers are greater than others so that we can order them. It's good to know what's smaller and what's larger, and what's on what side of 0, that type of thing. So we have 8, negative 7, 0, 1, negative 1, and 3. I told students to think about temperature with these. If we've got negative degree weather, that's a lot colder than positive degree weather. So the more negative your number, the colder it'll be. The more positive your number, the more hot it will be. So we should have come up with this. Negative 7, negative 1, 0, 1, 3, and 8. That is the correct order from least to greatest. Rewrite the expression below by replacing the circle with the correct comparison symbol. We have two numbers here, a positive 5 and a negative 3. Now they're just supposed to figure out, are these two numbers equal, or is one of them bigger than the other? Well, we should be able to tell that 5 is greater than negative 3. That's this little symbol, greater than. It's like the little alligator symbol. The alligator is going to open its mouth towards the larger number, in this case 5. Alright, we can also show addition and subtraction on the number line. This isn't something that the students will have to do a lot of, but it does come up every now and then. And it's a good resource in case later on they forget how to subtract and get into negative numbers and that type of thing. So we'll go over how to do this. 1 plus 2. We know that 1 plus 2 equals 3. But to show that on the number line, we have to start at our origin, which once again is 0. We always start there when we do these. Now we look at our first number, positive 1. So we're going to go in the positive direction over 1. And from there, it tells us to add on 2. So we're going to plus 2, go up a level here. And we're going to go over 2 more. 1, 2. And we end up at 3. So that is how that's how addition was pretty much made up from the number line. So that's 3. 1 plus 2. Here we have 4 minus 1. Remember, start at our origin again. Over 4. Okay? Went all the way over to 4. From there, we subtract 1, which is in our left direction, over 1, and once again we end up at 3. So yes, 4 minus 1 is 3. Alright, so anytime you see a minus, we're going in the left direction, the negative direction. Anytime we see a positive number, we're going in the right direction. Oops. 2 minus 5. Start at our origin. We're going to go over 2 in the positive direction. Okay? From there, we're going to subtract 5. So we're going to go 5 units to the left. 1, 2, 3, 4, 5. And we end up at negative 3. Alright? So that is how we do addition and subtraction on the number line. Now, something to note, notice that for 2 minus 5 we get 3, but it's negative. So the thing to notice is 5 minus 2, that gives us positive 3. But if we switch them around, 2 minus 5, we still get 3, but it's negative 3. So keeping that in mind, we can take any two numbers, even if we take a smaller one minus a larger one, we can do our normal subtraction. But the thing we have to notice is that we're taking a smaller number, subtracting a larger, which means we're going to end up in negative territory. But as long as we know that that's the case, we can do regular subtraction and then just add a negative sign to the answer. So it would look like this. I'm going to take 465 minus 322. Going to subtract those. We get 3, 4, 1. 143 is the difference. But, once again, we have a smaller number minus a larger number. This is actually negative 143. Okay? So just a simple way to do subtraction, even if it looks a little different. Oops. Now, sequences. Sequence is an ordered list of terms that follows a certain rule. For example, we have our even numbers and we have our odd numbers. Here are our evens, here are our odds. We notice that in between each term, all we do is add 2. 0 plus 2 gives us 2. 2 plus 2 gives us 4. 4 plus 2 gives us 6. 1 plus 2 gives us 3. 3 plus 2 gives us 5. 5 plus 2 gives us 7. And we continue in that pattern forever in the positive direction. Could also go in the negative direction. Negative 2, negative 4, those are still even numbers. Negative 1, negative 3, those are still even numbers as well. Or odd numbers, sorry. Now what we would call these two are arithmetic sequences because we are adding. Whenever we add the same amount each time, it's called arithmetic. And a good way to remember that we add for those is that this starts with an A as well as adding. Okay? So, arithmetic sequences, you add the same amount each time. The amount that we added here was 2. There was also 2 over here. These are both arithmetic. The other type of sequence that we have is called a geometric sequence. And that's because we multiply by the same term each time instead of adding the same term each time. So here's an example of one. Between 1 and 2, we're just doubling. 1 times 2 gives us 2. 2 times 2 gives us 4. 2 times 4 gives us 8. 8 times 2 gives us 16, and so forth. Our next term would be 32. We just keep doubling. That's a geometric sequence. we're multiplying by the same term each time. The next term in this sequence would be, well, it looks like we're multiplying by 3's. 1 times 3 gives us 3. 3 times 3 gives us 9. 9 times 3 would be 27. So we just keep multiplying by 3's in that term. That is a geometric sequence. What are the next 3 terms in this sequence? First of all, the thing to notice here, this is neither geometric nor arithmetic, but it does follow its own little rule. There are 2 different ways to do this. Basically, between each term, we're adding by odd numbers. Here was 1 plus 3 gives us 4, 4 plus 5 gives us 9, 9 plus 7 gives us 16, so our next term would be plus 9, which will give us 25, plus 11, our next odd number, that will give us 36, and our next one, plus 13, that will give us 49. So the next 3 terms are 25, 36, and 49. One other way to do this one is the same as 1 to the second power, 4 is 2 to the second power, 9 is 3 to the second power, 4 to the second power is 16, 5 to the second power, 6 to the second power, 7 to the second power. So, 2 different ways you could have done it, neither arithmetic nor geometric, but it's got a cool little system nonetheless, and it's kind of like a little puzzle, so it's kind of fun to figure out. Alright, our last one here. This one seemed to trip up a lot of students, but it's a very easy process. They say the rule of a certain sequence is k equals 3 times n. Find the first 4 terms in that sequence. Okay, the first 4 terms, that's what we're looking for. So term 1, 2, 3, 4. Here will be our result. Wow. Alright. Now all we have to do is we have to take 1, 2, 3, and 4 and put those in for n. Alright? So if I put 1 in for n, I get 3. Here, let's make this result. Okay. So k equals 3 times 1, that gives us 3. So here we get 3. If we put 2 in for n, we'll get k equals 3 times 2, which will give us 6. If I put 3 in for n, we get k equals 3 times 3, which equals 9. And now at this point we should be able to see we're just going up by 3's. First term 3, second term was 6, 3, 6, 9, 12. Those are your first 4 terms of the sequence. Alright, once again, lesson 4 for 7th grade. Homework should be out on the homework link. And we'll see you next time.
Just a reminder to the web leaders that we'll be meeting in Miss